So now we are going to go into an important law called as Gauss law that makes it very easy to find the electric field or electric flux due to charge distributions in symmetrical objects. Rather than doing the kind of the loop and the plate example we did, there is an easier way you can apply by using this Gauss law. So the total electric flux cutting through a closed surface. What do you mean by closed surface? A closed surface is a volume. You will realize a volume when you have the surface is closed. An Aladdin's carpet is an open surface, yeah? So you go and wrap that carpet so that all the edges are all touching each other. Then you created a volume law. That surface is closed. So such a closed surface, this circle denotes a closed surface. That electric flux is going to be proportional to the charge enclosed. Interesting, right? And it's kind of intuitive as well. So you take this plus Q charge here. You know that the electric field is going to be all pointing like this, isn't it? If I were to take a closed surface like this, and if I were to find the electric flux that is coming out of the surface, that means if I do the E dot ds along that surface, the closed surface, it is going to be equal to this charge enclosed, which is plus Q over epsilon. It's going to be proportional to the charge enclosed. That's what Gauss law says. So notice again, since there is an epsilon, I can bring the epsilon to the right-hand side. So it becomes epsilon E is equal to D. So in terms of electric flux density, so this is electric flux density, this is being electric flux density. And the unit of electric flux density is coulomb per meter square. And the unit of this guy is meter square. Coulomb per meter square times meter square becomes the unit of this guy, which is coulomb. So dimensionally, it's correct. So closed integral d dot ds is the total electric flux that is coming out of a surface S is equal to the charge enclosed. Is equal to the charge enclosed. So this surface can be independent. It can be any shape. Yeah. For example, if this is plus Q, need not be a sphere that I consider. The shape can also be in any way. Yeah. But such a surface is called as a Gaussian surface. As long as it encloses the charge, the total flux that comes out of that surface is going to be equal to the charge it encloses. So this becomes very useful when there is certain symmetry to find what is the electric flux density directly.